Welcome to the Green Parking Council webinar on EV charging infrastructure. This presentation is part of our continuing series of informational webinars on sustainable technologies and programs in parking facilities. I am Trevor Mead, Green Parking Council Staff Associate. First off, if you encounter any technical problems during the presentation, please email Gretchen Brown at gretchen@greenparkingcouncil.org or send a chat message to the presenters. The deployment of EV charging infrastructure throughout North America offers parking facilities the opportunity to play a critical role in the adoption of electric vehicles. Today's webinar will provide an overview of available charging methods and the open source protocol that allows charging stations to operate as a single flexible network. The presentation will highlight the most contemporary charging method, Level 3 charging, also known as DC fast charging, and what this technology means for the parking industry. An included case study will give participants an understanding of the opportunities created by the open source networking of Level 3 charging stations. Today's presenters are Andy Bartosh, Manager of Projects and Service for ABB's Electric Vehicle Charging Infrastructure Business Unit across North America, and Brett Hauser, President of Greenlots North America. Please enter any questions you may have into the chat box located on the left-hand side of your screen. We have allotted 15 minutes at the end of the webinar to go through the questions we received during the presentation. The webinar will run no longer than 1 hour. Without further ado, I would like to introduce Andy Bartosh. Andy Bartosh is the Manager of Projects and Service for ABB's Electric Vehicle Charging Infrastructure Business Unit across North America. ABB is a $40 billion global engineering, products, and services company with expertise in power and automation. It has the largest installed base of DC vehicle chargers in the world. In the summer of 2012, Andy joined ABB's EV Charging Infrastructure Group for growth in North America, as it expanded from early successes in Europe. Andy is currently responsible for planning and executing turnkey projects for EV charger networks. He is also heavily involved with product and business development. Andy joined ABB in 2008 as a project manager for ABB's Advanced Power Electronics business, where he managed several multi-million-dollar projects for various government and commercial customers. These projects provided customers with custom power supply and battery energy storage equipment. Andy holds a Bachelor of Science degree in Mechanical Engineering from the University of Wisconsin-Madison and a Master's of Business Administration from Marquette University. Andy?
Thank you, Trevor. Hi, everyone. Again, I am Andy Bartosh with ABB. I am sitting in New Berlin, Wisconsin, just outside of Milwaukee. That's kind of where our group is headed out here in New Berlin, with a heavy focus on the West Coast, clearly. So I wanted to give you a brief introduction. If you don't know ABB, our company, again, is Automation and Power. ABB has existed as ABB for a couple decades and have really been in the EV business starting in Europe maybe 3 years ago, and just last year started in North America. So I want to give you a brief introduction on just electric vehicles, cars, and charging for those of you that are less familiar. Hopefully I'll be quick for those of you that are familiar. First off, I want to explain just the different types of vehicles we see. So I've got this in two categories in rows. And the top row is non-grid connected. So you're looking at anything from fuel combustion, which are typical in internal combustion engine, hybrid vehicles, and fuel cell, to name a few. Then the grid connected is where we come into play. The plug-in hybrid electric vehicle, you see an example like a Chevy Volt compared to a battery electric vehicle, somewhat of a Nissan Leaf or otherwise. The two comparable things to look at here, the thing I like about this image is that it shows some proportionality between the vehicles and what is in each. So in a hybrid vehicle like a Prius, you see the small motor and a small battery pack. So it's clearly not the main source of propulsion for the vehicle. Whereas in the plug-in hybrid and the battery, you see comparably sized electric motors with the battery size really being the main difference. And obviously the plug-in hybrid has a gas engine. So I think many of you are familiar with that. Then the charging of these vehicles is the key. I show AC and DC charging. I always like to answer this question up front because a lot of people hear articles about what's better, AC or DC. One of the common things to know is that to charge a battery, you have to be charging via DC. So it's more on the element of, is your charger on board in the vehicle, or is it on the curbside or near the parking space? And we call this capital efficiency to minimize weight, size, and cost within the vehicle, we share that infrastructure across these DC fast charging stations. I think that's all I need to tell you on that. Now, you heard Trevor say level 3 charging. Some of the nomenclature is getting tossed around. I wanted to use this slide to give you all some of a background as to what FAE is doing, and I think that's probably a good baseline for us to use in this presentation and in most situations. So AC level 1 you see on the left is AC. Level 1 is plugging into a standard outlet like a toaster. Level 2 is something you see more on the commercial. You've seen these go up at certain grocery stores, Kohl's department stores, things like that. We call that AC level 2. It's a fast AC, but it's a slow charge in the ABB world for where we do most of our focus. So ABB focuses heavily on DC charging, and the difference between level 1 and 2 is simply a max power output. The plug is the same, so up to 40 kilowatts in level 1, up to 100 kilowatts in level 2. So I guess I'll get more into our core products, but DC charging is typically quite a bit faster than AC charging, and we talk typically in orders of magnitude of 10 to 20 times. But I'll get into that a little more, but I wanted to show you within the standards then, if this is our level 1, level 2, here are the standards that you're going to see in the plugs. So I show that a lot of you have seen the J1772 plug is what you plug in most of the infrastructure. So the charge point and the blink type equipment that you see a lot of today uses this connector, and it's kind of universal. It's applicable in purely electric vehicles and hybrids. And right now, the DC charging is typically only on the purely electrics, but we're seeing kind of a shift there I'll get into. You see two main DC charging standards here. I'm not showing some of the proprietary ones like Tesla, but the Center One CHAdeMO was introduced by Nissan and its partners back in 2009, and is being heavily used on the Nissan Leaf to date. The CCS or the SAE combo is a new plug that's standard was finalized in November of 2012 and is in current rollout paths with GM and BMW and Volkswagen are probably the most common to date that are truly active. So let's show just a general mapping of vehicles that we're seeing roll out. I try to show this to say the general trend is to go to DC charging, and as I mentioned, even some of the plug-in hybrids are starting to at least look at that for future models. But AC charging is certainly part of the picture. I don't know if any of you saw us at APW, our event at ABB. We had a Zero Model S, the motorcycle in the middle there. Exciting to see non-passenger vehicles, venturing into new realms there. So that's the cars and the technology. I guess I just wanted to check for questions. No one's typed in anything yet. That's good. The general market outlook then, it starts with stakeholders. So who's a stakeholder? I mean, realistically, the question to me is who is not a stakeholder, and I think the answer is no one. But you see, everyone has a different interest and responsibility in this. So EV users clearly are very interested, but the impact they have is sometimes limited in scope. So we see a lot of things starting off in this early adoption mode, heavily incentivized by government and utilities to get this off the road, or on the road, I guess, is a better statement. But you see, as far as stakeholders, as I mentioned, everyone is a stakeholder, and it's certainly more than OEMs and equipment suppliers like ABB. There's certainly plenty, city, government, and otherwise. So within that, just some projections on electric vehicles. So the forces pointed inwards, you see, what are the really drivers? Environmental concerns, government push, I certainly mentioned that as a stakeholder. Energy security, that's one of our big selling points on electric vehicles. I mean, we recognize there's still a carbon footprint to producing electric vehicles and its infrastructure, but you certainly have more secure domestic sources for that. Oil prices and technology progress. Then within the circle, you see some projections for electric vehicles. Now, this is plug-in or fully electric, but 30% by 2030, I think may be a bit ambitious, but I think we'll be closer to that than zero, certainly in that time frame. So it's certainly a growing market, and when you put numbers on those figures, 30% of the millions of vehicles that are just in North America alone, it's a significant volume. Moving on to the prerequisites for large-scale EV adoption. I mean, this is there's a lot of elements involved here, and I think the first bullet there is one of the keys: an affordable, attractive EV. Right now, if you don't like a Nissan Leaf or a Mitsubishi i-MiEV, you either have to buy a Tesla or you don't have too many options. So exciting to see more manufacturers get involved. And then the other bullet's a little more technical, but cost of ownership. Certainly there's the economics that every buyer takes into mind. And the infrastructure, we always play the chicken or egg game, which should come first. So between car OEMs and companies like ABB, which should come first? The infrastructure certainly adds to the comfort level of the drivers. So in saying that, I always stress the fitting the driver lifestyles. That sub-bullet there is the key. So finding the balance of where do the chargers need to be before people will buy a car, and if people are buying vehicles, where do we need to be to support them to truly grow that market? Then I wanted to just look at ABB's involvement in this business. So on the grid side functionality, you've got three main circles here. Grid side functionality, ABB is heavily involved on the utility side, doing transformers, electrical equipment, services on those levels. So ABB's got a strong presence there. Charger management functionality, obviously being the manufacturer, we are supporting our chargers with our back office. But then the transition to consumer functionality is always something that ABB is trying to steer clear of so that we allow an open free market for that. So companies like Greenlots, who you'll hear from Brett in just a moment, manage that functionality. I see a couple questions. Let me just take a look here. If you don't mind, I will answer those then as we get through. I think I'll cover a couple in the product slides to come. Now I'll get back into a little bit more of an ABB plug and where the technology is going. So again, stress the fitting the lifestyle of the EV driver. This slide, you've got a whole multitude of ways to charge right now, and the main thing to differentiate is highway charging or highway fast charging. The lifestyle of stopping at a gas station the way we do today is different for EV drivers. So DC charging, I try to show with the proportionality of these two circles. DC charging is a smaller piece, but it's certainly a critical piece for public adoption. So what I like to think of is the small circle that is DC charging is the more dense circle that maybe even has a larger gravitational pull, if you will. So the AC charging is revolving more around the DC charging, but we can debate that all day. But again, finding products and locating those products in the position to best match the lifestyle, where DC charging is where it needs to be at convenience stores, off highway, short stop parking environments. AC charging, home and office for full workday. I think we all recognize that 70, 80, 90% of charging is going to be done on AC charging. It's just the reality of, again, fitting the lifestyle. And then the overlap of 30 to 90 minutes, we've got some new products that I think address that market better than some of the misapplication of both AC and DC chargers we've seen to date. So with that, I have my portfolio. I see a question from Michael. What are the different usage profiles and what is the best matching charge system? So I hope I'm answering that question then with this, is that, for the ABB portfolio, we've got our Terra 51 charger. 50 kilowatts can charge a car anywhere from 10 to 30 minutes in a typical charge session. So that fits that small DC sphere alone. The Terra SC we have is a 20 kilowatt charger. Does a very good job of charging during a typical stop to, like I said, a grocery store, a theater. Anything from a 30 to 90 minute charge is very common. And I won't pitch on our software functionality too much, but if you're looking at operating, we do a kind of a small package to support users. But again, I'll let you talk more about with Greenlots, that presentation to come. So one of our exciting fits to the market is this happy medium of having a DC fast charger alongside the AC wall boxes. So we're seeing a lot of interest in this for workplace charging and moderate duration parking structure. So I think it's a very good solution for many of the people on this call, as AC, again, is a predominant method of charging, but having the option to do a charge in a shorter period is a great fit. So come in for a meeting, stop in for lunch, something like that. Those type of visits are critical to have that sort of infrastructure in place. So I'll hopefully get some questions on that and be able to talk a bit more, but I won't go too deep into it right now. Wanted to also show just the generic data architecture. So when you saw the three spheres of grid side, charger, and consumer, we kind of show that in a different way here, where you see the top section is our charging equipment itself going into a server data layer, where we manage that. We manage our chargers from our data layer, and then there's also another interface of our Galaxy software or other APIs, again you'll hear from Greenlots, to really run that system. So the grid side is kind of another box. So the grid side functionality circle that you saw is a box really not shown, but it's tied very much in between the U box and the network operating center. So we are working on products that are more flexible to utility requests for smart grid load balancing, things like that. And with that, I think the main question for most of you is what is it actually going to cost me to put these systems in? I mentioned there's a lot of misapplications of AC chargers and 50 kilowatt DC chargers where it's just not quite the right fit. So there's a huge balance in finding the right fit for the right product. And these numbers are very rough. I'm sure some of you have examples of better or worse cases, but it's a snapshot of where I think we are today. And then I just wanted to talk briefly about the ABB successes. So I mentioned that ABB is the global leader in DC charging. Certainly much of that success is with a couple of years head start in Europe, but I highlight a couple of projects there in Estonia and Denmark. For those of you that don't know where Estonia is, it's right across the sea from Finland, connected to Russia, and that country made a decision to roll out an entire network of government, so it's subcontracted to ABB to run them, but government-funded stations to support the adoption of EVs. Then I highlight one of our more recent active public cases is British Columbia, which Brett will talk more about in his presentation, but Vancouver area and inland and on Vancouver Island, taking that step, the government, to get these chargers on the road. I see another question from Rick. Is there a system that connects both a traditional pay station to a charging station? If I understand that correctly, something along the lines of maybe a parking payment system built into a structure or a lot. Yes, we've done integrations with things like that. I think what I'll do is let Brett talk a little bit more about how OCPP can allow that. But in essence, we can integrate with an existing pay station relatively easily. And then a follow-up question, why is the installation for the DC level 2 more expensive than the AC level 2? Let's go back to that slide real quick. So DC level 2, I think I show the low side being comparable, but the high side being potentially higher. So I'm not sure. I think that's understood because there's a higher power requirement. So AC level 2 is substantially the lower power requirement. DC level 2 is a higher power requirement and typically takes a three-phase power, which is also kind of a different story. So hopefully that answers that question. Michael asks about utility incentives for well-behaved managed charging. And to my knowledge, not yet, but we'll see about that. So before I burn up too much time, I think we can come back to questions more later. But that's me, Andy Bartosh, contact information at ABB. For those of you interested, I think you'll get it also after the presentation. And so with that, I think I'll hand it back to Trevor to introduce Brett.
Thanks, Andy. I'd now like to take a moment to introduce Brett Hauser. Brett Hauser, president of Greenlots NA, leads the company's business in North America with a particular focus on facilitating company partnerships and ongoing expansion efforts. In coordination with the board of directors, Mr. Hauser is responsible for developing and implementing the company's strategic roadmap, introducing new solutions and services while leveraging the existing projects that Greenlots has successfully deployed around the world since 2008. Mr. Hauser currently serves on the Los Angeles Economic Development Corporation's E-Mobility Task Force and the California Public Utilities Commission's Sub-Metering Protocol Committee. Prior to joining Greenlots, Mr. Hauser served as Chief Operating Officer for EV Connect. While at EV Connect, Mr. Hauser was instrumental in securing key infrastructure grants, negotiating and managing relationships with auto manufacturers, electric vehicle supply equipment manufacturers, and software companies in the energy management space for EV Connect. Prior to joining EV Connect, Hauser spent more than 18 years in strategic and financial planning, product management, and business development roles. Most recently at Columbus Nova, a Manhattan-based private equity investment firm, Hauser was responsible for restructuring various multi-million-dollar corporations in telematics, mobile resource management, telecommunications, and natural resources. Hauser earned his Bachelor of Science degree in Finance from Combs School of Business at the University of Texas at Austin. Brett?
Thanks, Trevor. And good morning to those on the West Coast. Good afternoon to everybody else. So I'm going to talk today about open standards for electric vehicle charging infrastructure. Before getting into that, just a little bit about Greenlots. Greenlots is a technology company that provides network management solutions for electric vehicle infrastructure. The company was actually founded in 2008 in Singapore with the original intent of importing electric vehicles into the country. Once they started doing that, realized that there was no infrastructure around to actually charge the vehicles. So from there, they got involved in both the manufacturing and deployment of hardware, smart charging hardware, and network management systems as well. As the company grew, we saw the opportunities in both Europe and North America. The operations were moved over to the United States, specifically in California. Also realized that there were a lot of large, power equipment manufacturers such as ABB, Eaton, Schneider that were going to continue to make the hardware, and from a scalability standpoint, didn't think that we were going to be effectively able to compete in both the hardware and software side. So we stopped manufacturing our own hardware, and today, only focus on the network management solutions, that we offer, and we'll talk about a bit today, as well as working with various utilities on some of the smart grid demonstration projects they've got, whereby taking open standards all the way from the charge point and finding various paths using those open standards to the utility back office. We have in the last 5 years deployed multiple solutions across 13 countries. BC Hydro, which you'll see up in the top left-hand corner, is one that we'll talk about at the end today. That was done in conjunction with, or is in process, I should say, with both ABB and Eaton, and is a good indication of how using open standards can work. Again, work with EPRI and Autodesk here in North America as well. Before getting started on open standards, I think one of the first things we need to focus on is the term operability, and what does that mean? I've heard it used multiple times for multiple purposes, and there's really three things today that interoperability is used to discuss. One is from communication from the charge station to the EV, and those are the types of interfaces or plugs that Andy talked about with J1772, SAE, and CHAdeMO. The other is used to talk about what I would really call driver roaming, which is someone that has a network management subscription being able to use that same subscription at any charge station they go up to, regardless of affiliation. The third interoperability, which is kind of where we're focusing the conversation today, is in the back end, and that's the communication between the charge station to the network management system. And here's some of the reasons why these questions keep coming up. And so again, I try to stay away from the term interoperability specifically because it does mean a lot of different things, but at any time, if you have any questions about the term and how it relates to one space versus the other, please let us know. Please let me know, and I'll try to answer that question. So if we look at the EV infrastructure market development today, to this point, it's predominantly been funded by by the government, subsidies. There's the Charge Point America program, Equitality's EV project was out there. So they subsidized the market dynamics and were able to get a lot of level 2 charge stations deployed in both residential and commercial locations. Although I think the intent was to limit at the beginning to limit the number of interfaces they had to deal with. What that has resulted in is a small number of proprietary networks for public infrastructure. So when we say proprietary, and I'll talk about this in the upcoming slides, that means you've got a charge station with a network management backend, and that charge station will only communicate with that specific backend. And you can't make a switch to another provider at any time that you feel that you want to, and that's caused a lot of pain points for people that are rolling off some of these grants who might have gone with a charge station and a software provider because it was given to them for free, and then as they've gotten into the business of charging, they find that there's another solution out there that might meet their needs, and what they're finding is that because they have a proprietary system in place, they essentially are locked into that solution with that hardware, and the only way around that would be to actually replace the charge station so that they could use another communication platform to communicate with the back end. So again, just talking about the reality of the proprietary networks, and these membership models are prevalent. Everyone that wants to use a charge station more or less has to become a member, and if they aren't and they want open access, they can do so, but it's at a price. I know Blink, if you are a top tier member, you pay $1 an hour, but if you're doing ad hoc charging and want to use one of the charge stations, you're paying up to $2 an hour. And as we know, pricing for EV drivers, they're very sensitive to price changes. It's very price elastic. So $1, adding $1 an hour to the charge is going to make people think twice about actually using the charge station, and ultimately would be into the overall consideration about moving forward to adopting an electric vehicle. Proprietary networks, again, also give you limited technology, choice of options. When you are locked in, you have to use whatever solution, whatever functionality that provider gives you, and at the price point that they deem to be reasonable, because ultimately they always believe that the cost of paying for use of their system is going to be cheaper than if you had to go out and fully invest in a brand new solution. And ultimately what that does is it kind of retards the growth of innovation, because there's no need, there's no market pressure on innovation, and there's no pressure on pricing. So as a site host, which I think most of the folks on here on the call today are in one way, shape, or form, one of the key things you need to be concerned with is the vendor lock-in. When you're selecting your network your network provider, also have to be concerned with the proprietary solution. Not only if you just want to make a switch for business purposes, but what if that company goes out of business and you've got a proprietary solution? Then what are you going to do? You've got an abandoned station. We've seen a great example of this actually in Hawaii with Better Place, where in Maui they had deployed a large number of charge stations with Better Place. And then, as most of you are probably aware, Better Place decided to pull out of the North American market about 4 to 6 months ago. So Maui was left with all these abandoned charge stations. And the only option that they have left to them now is to actually pull those charge stations out of the ground and replace them. So monies that could have been used to further deployment of new infrastructure is actually being used to replace infrastructure that is no longer viable. That's got to be, when thinking about it from a site host and looking at your contracts with both your hardware provider and your network provider, let's say trust but verify. Make sure that the hardware and software conforms to open standards, which I'm going to talk about in a little more detail in the next few slides. But also one thing that is extremely important is ownership of the customer data. I think a lot of people don't realize by signing up with some of these agreements that they're actually giving over the rights to the customer data. So customers might be coming into your parking garage, coming into your parking lot, and you might be getting the revenue through the system for them using it, but you do not own that data. And concerns about how that data is going to be accessed and utilized in the future should be of significant importance to site hosts, not only because of what will be done with that information elsewhere, but I think there's also value in that, in having that information for the site hosts, and you should be able to access that. And most solutions out there today don't give you, as a site host, you have visibility to it through the solution, but are not given access to use it for other purposes, especially if you're looking at possibly switching systems. In some cases, you would have to let that data go and start from scratch. So the good news is there is a movement towards what we call open standards. Open standards essentially allow a site host to mix and match various hardware manufacturers with the right software solution. So in other words, if you have an ABB fast charger and you've gone with Greenlots, which we would be very appreciative of, we have to earn your business every day. And the fact of the matter is, if you don't like the way that we're performing for whatever reason, at the end of our contract, you have the right to switch. And to make that switch, you shouldn't have to pay anything additional. You shouldn't have to pay for any additional hardware. You should be able to just make a decision with another vendor and point to their service. And that's really what Open Standard is about. It's giving control and ownership, control back to the site host to make business decisions based on the value proposition and the price point that both the hardware and network service provider is going to give to you. Promoting open standards from a business standpoint for Greenlots, it's certainly allowing more competition into the market, but that's okay. I mean, for two reasons. One, we believe we've got a very strong product, and on apples to apples, feel that people are going to pick our solution more times than others. But the other side of it is that we welcome the competition because we all have a responsibility to see this industry grow, and more competition is going to create further demand, further innovation, and it's also going to lower the price points on what people are paying. Currently, in the state of, or I should say, in the country of Europe, where some open standards in this space were actually originated, and they use a standard called OCPP, which I will get to in a second once I get my login back to the system here. Bear with me just a second. Trevor, if you could possibly just drive the slides forward because I've lost connectivity.
Yep, I'm on.
Okay.
Sure. You're on OCPP now.
Yeah, great. So talking about OCPP, which is a standard that came out of Europe. The European standards had when they started off too, they had multiple proprietary networks, but the Dutch government specifically couldn't get access to the information to understand who was using it, the utilization, how to do proper siting for charge stations. So they made a movement with a consortium of Dutch utilities called ELAD to form the OCPP Alliance. OCPP stands for Open Charge Point Protocol. Has nothing to do with the company ChargePoint, so I want to distinguish that. But essentially now in the European Union, any public funds or public tenders that go out for EV infrastructure require the use of open standards for any hardware or software solutions. So if we could, I guess, move on to the next slide here.
I got you. Case study BC Hydro.
Okay, BC Hydro, thank you. Let me just get to it on my own thing here. So British Columbia expected to have one of the highest EV adoption rates in North America for the following reason. They have the highest differential between the cost of electricity and the price of petrol per liter. And their adoption rates hybrid vehicles, which has been a strong indicator of adoption rates for plug-in and all-electric vehicles. Is their adoption rate is 2 times higher than the rest of Canada. I think they're trending at 1.7%, where the rest of Canada is at 0.7% of new cars sold. And then 73% of population is concentrated in urban areas, and 95% of the trips are less than 30 kilometers. So BC Hydro is ultimately going to be deploying 30 to 35 charge stations, DC fast charge stations. They've initially gone with 13 DC fast chargers, and that's been split between ABB and Eaton. And there's 2 different charge stations, but they are both OCPP enabled. And because of that, BC Hydro is able to have one network management solution. Fortunately, it was Greenlots Scott that was selected to manage the various locations. So it doesn't matter what hardware is being used, the consumer will have the same consumer experience at the front end. And that's not only from using the same form of payments, whether it be a mobile app, which you can use scanning a QR barcode on the charge station, an RFID card, or you can, of course, call in to our 24-hour customer support, and they can take your information online and enable start and stop the charge remotely. And in the future, probably have credit card swipes as well, because with all the talk for interoperability or roaming, I think we truly believe that having a credit card is the greatest form of interoperability there is. Most of us had them, unless maybe you had a bad credit problem in college or something. So everyone's got a credit card, and that serves as sufficient use, as sufficient roaming. And the other thing that they wanted to make sure was that someone wasn't forced to have a membership in order to participate in using any of these vehicles. The other thing that I say is unique about our solution is that the customer support it's really more than just superficial, with which you'll find from other providers. We triage the issue at the front end, and a lot of times it could be driver issues or driver errors. But if there is a problem with either the software or the hardware, we have a fully integrated system with our technical people as well as ABBs and Eaton's, so that the problem from there gets escalated, everyone's notified, and then a resolution is brought to bear. Whether that is something that can be done remotely with over-the-air updates, or a truck needs to be rolled to fix the problem, that contact has already been made and that process has already started, irrespective of who the software provider or hardware provider is. So if we can just move on to the next slide there. I thought it was just interesting for everyone to see this. The top part of this slide right here kind of shows the ownership structure of these charge stations. So BC Hydro, as utility, owns the charge stations, but they have leased them back to the 13 different municipalities. So there's 13 different munis that are participating in this, and each one of those munis has a lease agreement for the charge station with BC Hydro, and they will be the operator. So even though BC Hydro has an overview, a network operator view of what's going on at every location, the relationships will also be directly with each individual muni. So as you can see from the diagram, people might be connecting in, whether it's an ABB charge station or whether it's an Eaton charge station. And again, you can add any other brand that is OCPP compliant onto there. All communication would come back through our network system, and both the munis and the utility will have perfect visibility to real-time information with what's going on in their system. So with that, I want to thank everyone for their time, and I'm sure there's questions. And as we're talking through the questions, I will try to get myself back online here.
Thanks, Brett. We'll jump right into some questions. First one is, do either of you have an idea of what the right prices for public charging and the role that the different levels of charging would play into pricing. So should there be an impact on how quickly you're able to charge your vehicle and what that charging rate is?
I mean, I can tell you within our charging equipment itself, so looking at a 50 kilowatt charger, we do have the ability to software limit the power that's output. We've not seen a use case that has a customer actively managing a different rate to a different cost. But anything is possible in that sense. But as far as the answering the question of what's the right rate, Brett mentioned that residents of the Vancouver, British Columbia area are more willing to pay than others. So obviously, the price of gasoline has a factor, but it also depends on the vehicle fleets that are nearby and the competitive charge stations nearby. So it's very, very variable right now, and that's leaving out the fact that there's certain government legislation that prevents you from selling electricity or other services at certain methods. So there's a lot of variables involved on the actual price structures.
And this is Brett. I would just add, to that, there, as opposed to telling you, what the price should be, I can tell you that there's been some studies done. I think if the Center for Sustainable Research, did a study. It said that, for level 2 charging, folks were willing to pay upwards of 70% more than they're paying at home for their lowest electric rate. So I say 70%, and on a percentage-wise, that seems high. But on an absolute basis, the number, the rate they're paying is 11 cents per kilowatt. So you're really only looking at going from 11 cents to 17 cents per kilowatt hour. As it relates to DC fast charging, some people are willing to pay 4.5 to 7 times what they might be paying at home for rates. So it starts to get up there, and with depending on the location of the DC fast charger, and the urgency of the charge, site hosts will probably play around with the rates. I mean, they do have, depending on the size of the charger, and I think, Andy, I think that's one of the reasons why your 20 kilowatt fast charger is attractive, is because it avoids some of the demand charges that utilities have. Isn't that right?
Correct. Yep. Absolutely. So that product was, our 20 kilowatt charger was developed pretty much for that case. I mean, it's a little sleeker form factor, but the driving force was to say 50 kilowatts ends up punishing a lot of site hosts in a lot of these EV hotbed areas. So the 20 kilowatt solution is certainly a key driver there in those markets.
Thank you, guys. That leads into another question that came in about peak demand charges and what role they play. How big of an impact do they have on costs when it comes to the faster charging methods, the cost of electricity?
Well, I mean, I'll give you kind of an additional piece to that BC Hydro case study. I know that there's some sites that were facing upwards of $300 to $500 a month of demand charges. So the utility, since the utility is sponsoring the project, a lot of these are going into separate metered fees so that they're not experiencing that. But yeah, it can certainly put a huge dent in any business case you'd make in for charging for fees for charging if you're paying hundreds of dollars a month for demand charges. So finding the balance of negotiating how that's going, how it's being installed, it's a key element, and it's why when I mentioned the range of installation costs, it's one of those factors too. So if you've got no concerns over peak demand, if you're in a geography that doesn't worry about that, and you've got power nearby, it can be very low on the cost. But if you have to do some workarounds, it can get pretty expensive.
Thank you. Next question is, what's the easiest way to monetize a charging station in a parking facility?
Well, that's a great question. I think if we had the exact answer to that, I'd be in Tahiti somewhere, or another location of choice. I will say this, that I find that it's it's very hard to find a real ROI with level 2 charging. And if you're trying to get to that point, then you're probably starting to charge the drivers such a high fee that it probably doesn't make sense for them to be driving that EV relative to the cost of gasoline. So that's level 2. And level DC fast charging on the other hand, and Andy, please feel free to jump in here. I do think that we are starting to see some business cases for that because of the speed with which you can charge, because of the fact that they are in these quarters, EV quarters that have been set up, and I think that the price is more. I think whereas we're more price elastic with level 2, it's a little more inelastic relative to DC fast charging. And there are models being put in place, kind of like a gas station charging model, where if you can get the volume and get people charging it enough, you can start to see some of that drop down to the bottom line.
Thank you. We had another question on tax credits. Somebody asked if there was a tax credit. They believe there was a tax credit limit for each company could only apply the tax credit to a limit of 2 sites. I'm assuming that they're referring to the federal tax credit in the United States. Do either of you know if that limitation is correct?
To tell you the truth, this is Andy. To tell you the truth, I'm not 100% sure one way or the other. I'd have to go read the citations that I've got up on the presentation right now in more detail. I don't know, Brett. Do you have a better feel on that?
No, I don't.
So I mean, I certainly feel free to contact me. I'm happy to work together with anybody facing that. If you're looking at doing more than 2 stations, it's certainly something that I think the government and car and EVSE OEMs are all supportive of multiple stations going up.
Great. And just so everybody knows, the contact information for both Brett and Andy will be up on the Green Parking Council website after this presentation, so you can follow up. Another question regarding tax credits came up. How can nonprofit entities take advantage of those? Is there a way for them to do that?
To take advantage, I mean, the tax credits for the installations themselves, I think, would be treated the absolute same. I think it'd be interesting depending on the geography and the fee structure. I mean, there may be. I know that there is language in some rate codes that allows you to resell more competitively as maybe a co-op or potentially a nonprofit. I don't have those details with me, but
there is. I was going to say there is. Whoever asked the question, if you want to email me afterwards, there is a paper that was done by David Peterson, who used to be with the Luskin Group, UCLA, is now with Nissan, about how not-for-profits could actually work around. I think it was with an operational lease. But if you'll send me an email, I can get that paper out to you, and that might be able to add some insight. Now, there is a way to do it that is above board. I just don't. I don't have the paper right in front of me, but I will send it to you.
Thanks, Brett. The next question is: are either of you familiar with the availability of 480-volt three-phase? Oh, the question just went up. Three-phase power charging infrastructure, and is this a major roadblock for DC fast charge?
So, how's that? Who asked that question? I see. Is that Daniel's question?
Yes.
Is it a major roadblock? I would say not necessarily, because the DC fast charging is going in places that it needs to go, rather than just popping them anywhere. It's certainly a strategic decision. Is it an obstacle? Yes, at times, certainly. But is it a roadblock? I would say absolutely not. There are cases, the case study in BC Hydro, I'll keep on that, where, locating power is a little longer run, or maybe in one case a line extension or a new service. But I would say it's more about finding the right location where you can make a business case for the charger than just sticking charging equipment where you can fit it, if that makes sense.
Thanks, Andy. Another question here is, can you talk to the availability of Level 3 DC fast charge equipment for the new CCS combo connector for SAE-equipped vehicles?
Certainly. This is Andy again at ABB. So there's not a UL product on the market yet. I can tell you that we're making shipments in Europe with our European combo charger in June. So those will start to appear on the globe in June. I think realistically, a UL unit in North America is more in the lines of Q4 of this year, and I think there's a lot of anticipation for that. I mean, ABB is among the one or two leaders coming out with those products later this year. So hopefully that answers the question thoroughly enough.
And then there was the question right above that, Andy. Since ABB can limit the amperage rate for their chargers, do those reduced rates satisfy electrical codes when designing electrical panels and circuits rather than the maximum potential rate to service the charging equipment?
So every installation we've done so far has still had their installation rated for the full 50 kilowatts, like the 55 kVA. I would say most likely not. Your inspector will probably not allow it. But what we can do, we've also been able to do chargers with fewer power modules themselves. So our unit is five 10 kilowatt power modules. So we can frankly pull power modules physically out before shipment, and that may satisfy your inspector a little better. But I'd have to look at your local codes in more detail and really talk to your local inspectors. That's the key. So my gut answer is that no, you'd probably still have to size the whole service for the entire rated power, but we can have that conversation in more detail as well.
Thanks. The next question, and our final question for today, is how about a combo unit capable of either CHAdeMO or SAE combo and the availability of that?
So I'll limit that answer to the North American market. That is the product that we are developing right now for North America. Our UL unit will actually be a dual outlet unit, so it will have the option of SAE, CHAdeMO, or both. And so that the timeline still is the same in the generic Q4 region right now.
Okay, thank you. With that, we'll bring a close to questions. I'd like to thank our presenters for taking time out of their day to educate us on this topic. Their information helps us gain a greater understanding of EV charging infrastructure and the opportunity it presents for the parking industry. As of tomorrow morning, this presentation, as well as our panelists' contact information, will be available on the Green Parking Council website. I encourage you to reach out to Andy or Brett with any questions that were not answered today. In addition, please email me with any suggestions you may have for future webinars at trevor@greenparkingcouncil.org. Thanks for joining us.
Okay, thank you, Trevor. Thank you, everybody.